Hello friends, MoNaCo here, video 3, unit 3, periodic table. We're going to talk about the groups of the periodic table today, and you're going to get more familiar with the specific names of each of the groups. The Easter egg today is not to sign up for the message, but there is a typo in one of the slides later on that I want you to find. If you can find that typo, then you come tell me what slide it was on, show me in your homework packet, you get yourself a STEM buck, because that means that you were paying attention to detail, and that is what's going to make or break you in Regents Chemistry. So thanks. All right, so let's get on with it. What is so special about a group in the periodic table? Well, the thing that's special about a group in the periodic table is that all of the elements in that group have the same number of valence electrons, and therefore they will react similarly to other elements. Okay, that's that one specific property they have in common, is that one valence electron or two valence electrons in the outside shell that makes them react chemically in similar ways to the other elements in the same group. We're going to get to know about the names in a little more in depth. Okay, the first group, group 1, is called the alkali metals. Okay, the alkali metals. You know what I just noticed? No, it's not this slide. This is not the slide that has the typo on it. But all the elements have one valence electron. They easily lose their valence electron to become positive 1 ions. Remember, when you lose an electron, you become positive. It's kind of opposite. Okay? They are extremely reactive, and therefore you never find them as pure or alone, as pure elements in nature. This contains the most reactive metal, probably francium. Francium, however you want to say it. Okay, we say probably because we as a human race have never gotten a large enough sample of this stuff to throw it in water and find out what happens, because it is so reactive and radioactive that it doesn't last for very long. So we generally go with the fact that cesium is the most reactive metal, and that's much more common. We can get a chunk of that and throw it in a bathtub of water and see what happens. The next group is group 2, the alkaline earth metals. And Mr. Milks taught me something just today. Notice how alkali metals is one word before metals. There's one word right here. Okay, then metals. And alkaline earth metals is one, then two words before the word metals. Therefore, it's 2, group 2. That's one way that he memorizes it, remembers it. I thought that was pretty cool. So all of these elements have 2 valence electrons, and they prefer to lose those valence electrons to become positive 2 ions. Why positive? Because when you lose an electron, you become more positive, because electrons have negative charge. Okay? These are fairly reactive, and therefore we never find them as pure elements or alone in nature. These are the types of elements that make up many of the rocks and minerals that you have studied in earth science. Okay? But they're as compounds in rocks and minerals and are never really pure by themselves. Okay? Because they are fairly reactive. Now we're going to move on to groups 3 through 12. Now some people call these the D group block, D group, the transition metals, the middle of the periodic table is what they're also called, the D block. We like to say that they form colored ions in solution, meaning if I took some iron and dissolved it in water, it would produce a nice brownish colored water, i.e. rust water. Other elements, such as copper, produce a nice blue color. And this is very, very common on the Regents. Which ion produces a colored solution when dissolved in water? And it'll give you like lithium, potassium, rubidium, and then copper. Copper being the only transition metals is the right answer. I'll try to make some solutions of these things like copper and cobalt solutions in class to show you. They tend to be unpredictable, which is why we generally leave them out when we're talking about trends and periodicity, because they lose or gain electrons depending on what other metals are present. So they kind of got to go decide what they want to do when they want to do it. There's a lot of exceptions to our trends and rules in the transition metals, which we don't get into because we don't want to convolute things. This is the least reactive group of metals. It actually contains the least reactive elements of all: silver, gold, platinum, all the very, very heavy, precious metals, which you can find in pure form out in nature. You can go find a gold nugget. You can go find a platinum nugget, a silver nugget. Because they don't react, you can find them lying around on the ground. So the next groups are part of the main group. It's the groups 13 through 16. These don't have a special name. They're just named by the first element at the top of the group, B, C, N, and O. It's not a single group. It's more like four, and the reason why is they're kind of miscellaneous. So we threw them all together as miscellaneous. There's metals in there, like tin. Okay. There's non-metals in there, like carbon. There's metalloids in there, like silicon. Okay. Found along the big, dark, thick, black line staircase on your periodic tables. There's many different properties all mixed in here. That's why we call it the miscellaneous group, BCNO. Okay. Now we're going to get into some of the named groups again, the last two. The halogens. Halogens, don't matter how you say it. They all have 7 valence electrons. They like to gain 1 instead of lose all 7 to become ions with a -1 charge. Remember, losing electrons makes you a positive ion. Gaining them makes you a negative ion. Now, they like that 8 is great rule, so that's why they gain 1 electron. Okay, if you look at their electron configuration, they've all got a 7 at the end there. They want to get to 8, so it's easy to gain 1. They form salts and compounds called halides. See how the names kind of related to the group? Okay, these were named hundreds of years ago, and that's why we kind of just still going with the flow here. They contain the most reactive nonmetal of all. This is fluorine, as normally a gas, but fluoride is in your toothpaste. So once it forms a compound, it's not very reactive, and it actually protects your teeth. So you're not going to find fluorine by itself out in nature because it's very reactive, just like you're not going to find lithium or beryllium. They're all non-metals, meaning that they're not metallic, they're not shiny, they're going to be brittle, they're gases. This group is interesting because it contains all 3 phases of matter in one group: solid, liquid, and gas. For example, as you go from the top of the group down to the bottom, things get more metallic. So we go from a gas to a liquid, then to a solid. Chlorine is a gas. Right underneath chlorine is bromine, which is actually a liquid. And then right underneath bromine is iodine. Now, you might think, well, iodine's a liquid. I had it at the hospital. They put it on my cuts. Well, that's an iodine solution. Iodine, the pure element itself, is actually a solid crystal. It's a dark purple crystal and is actually very toxic as a pure form. So as you go from the top of the group to the bottom, we're going from a gas to a liquid, then to a solid. And that pattern continues. Antimony is most definitely a solid. It's actually almost silvery and metallic-like. So we go from non-metallic character to metallic as we go down this particular group. Put that note in there for now. We're going to revisit that in a later video. And this is the slide, if you can find it, where the typo might be. Boop. Group 18, the last final group, the noble gases. Yes. The nobility lives here. These are the last elements ever discovered by scientists because they are unreactive, or synonym inert. They're hard to find. Okay? They already have that stable octet of 8 valence electrons in that outside shell. Look at your electron configurations. All of them have 8 in their valence shell. Therefore, they're most stable, and they exist alone in nature, and they're very hard to find in nature because they exist alone. The exception to the octet rule is helium, which only has 2 valence electrons. It's up above the group there. The examples of a halogen would be neon. These types of elements are also used in a lot of really high-end projector lamps. Okay? We fill the projector bulb with xenon gas because it doesn't react with anything, and it keeps the projector light bright longer. A lot of headlamps in really high-end BMWs or Mercedes-Benz have noble gases inside their bulbs because it prolongs the life of the bulb and they stay brighter longer. Okay, just a little trivia there. That could be an Easter egg too. Come and tell me what the noble gases are used for. I might have a little something for you. So there's 2 Easter eggs in this video. One typo, and what do you use a halogen for? I'm sorry, what do you use a noble gas for? Hydrogen by itself is not officially a part of any group. It's kind of a loner. It's both a non-metal and a gas. It can be seen as H2 gas, H plus aqueous, or H minus aqueous. We'll see those more in the acids and base unit. And the last 2 groups, lanthanides and actinides, they're kind of like the forgotten children there. We don't really pay much attention to them. If we included them, then the periodic table would actually take up, I don't know, about 3 more feet wide, so we don't really deal with that. They actually belong to the transition metals, and they're kind of cut out of the periodic table because we don't really do much with them. We know that uranium and plutonium are in there, but beyond that, we don't really talk about them much because they are even more complex than the transition metals in what they do and how they do it. So we don't want to make things any harder than it has to be. Your practice is short response this time around. Do it. 4, 9 questions on the previous video and possibly the previous 2 videos, okay? So at this point, you should be able to do practice package page 13, 14, 25, and 29, some word fills in there. And definitely make sure you sign up for my text messages. You're not getting that Easter egg this time, but there were already 2 in there. Thanks, Bo.